The next problem I'm going to work on will be question number 6. I had to put this into 2 videos because my phone kept ringing, and I'm sorry about that, but I had to stop. So this is section 1.7 now, part 2. So in number 6, we're given the parametric equations x equals 1 plus 3t and y equals 2 minus t squared. Once again, we're asked to plot this and to use an arrow to show direction. I'm not going to do that. That's just plugging in points. I already did that in question number 2. It's exactly the same steps. I don't see any reason to sit here and plug in t is -3, t is -2. They did not give us a domain over here, which means t is an element of the reals. But if you plug in -3, -2, -1, 0, 1, 2, 3, you can get a good idea of what the graph looks like. And those are typically the points we use to try to establish a curve. So I'm going to work on 6b. 6b says eliminate the parameter to find a Cartesian equation of the curve. Now, how do we do that? How do we eliminate t? Well, we start with x equals 1 plus 3t, and we're going to solve for t. If we solve for t, we get x minus 1 equals 3t, or x minus 1 over 3 equals t. I'm going to write that as x over 3 minus 1/3 equals t. Now, from here, what are we going to do? We're going to substitute into our equation for y. Okay, so we're going to come over here and we're going to have y equals 2 minus, and then we have x over 3 minus 1/3. That's t, and that's going to be squared. And now we're just going to FOIL and be done. So if we FOIL this out, here's our 2, right? 2 minus. If we FOIL, this is going to be x squared over 9. Then in the middle, we're going to have x over 3 times -1 over 3. That's going to be x over 9. And we're going to have 2 of those. So that's going to be minus 2x over 9. And then when we FOIL, our last term is going to be -1/3 times -1/3. That's going to be positive 1/9. Now, if we clean this up, right, if we simply, let's factor out a 1/9, we'll have 2. Well, let's don't do that. That's probably, we got to put that 2 in this positive 1/9, or sorry, -1/9 together. So 2 is 18/9, right? 18/9 minus x squared over 9 minus a minus makes that plus 2x over 9, and then minus 1/9 here. And so what do we end up? We end up with negative x squared over 9 plus 2x over 9. And then here we have 18 over 9, take away 1. That's going to be plus 17 over 9. We could factor out a -1/9, and we get here x squared minus 2x minus 17. And we have eliminated our parameter t. All right. On to the next problem. The next question I'll work on will be number 11. 11a says, eliminate the parameter to find a Cartesian equation of the curve. And in 11, we're given x equals sine t, y equals cosecant of t, and we're given bounds that 0 is less than or equal to t, which is less than or equal to pi over 2. Now, because we're given bounds on t, we're going to have to find our domain and our range when we eliminate our parameter t. Now, how are we going to eliminate the parameter? Well, we don't want to solve for t like we did on the previous example, because that would give us inverse sine of x equals t, and then we would have cosine of inverse sine, and those are not things that we're very adept at solving. What we can do, I'm sorry, I said cosecant and wrote cosine. but number 11 is cosecant. So what we can do here is we can observe there's a relationship between cosecant and sine. Y is equal to cosecant of t, but that's 1 over sine of t, and sine of t is x. So our elimination here is just y equals 1 over x. So this is our equation in rectangular form. And now we need to find its domain, right? That's what we're going to focus on. So if we think to ourselves, what about x? Well, now remember, t is bounded below by 0, so that x would be sine of 0. That would give us 0. X would be also sine of pi over 2. What we're looking at here, we have the graph of sine from 0 to pi over 2. Well, the graph of sine from 0 to pi over 2 looks like this, right? This is our, I'm just drawing a graph of sine, and I'm stopping at pi over 2. So we can see that x starts at 0, and it passes through all the real numbers all the way to x equals sine of pi over 2, which is 1. So x is an element, these are equal to, so it's an element of the closed interval from 0 to 1. Now, what about our values of y? Right? What about our values of y? Well, there's a couple of ways we could do this. One way we could do this is we could just graph cosecant. If we remember how to graph cosecant, we graph cosecant by first graphing sine. Here, I'll do the whole graph just in case you've forgotten how to graph cosecant. You draw the graph of sine. Cosecant has asymptotes when sine equals 0. After all, cosecant is 1 over sine, so we can't have sine be 0. And then the way we graph cosecant, I'll change colors here, is we know that at -1, 1 divided by -1 is going to be -1. And so if we graph cosecant, cosecant looks like this. Now, we're trying to find the range, right? We're trying to find the range. We're trying to find what is y. Y is an element of. Now, we're only worried about the part from 0 to 2 pi, right? That's the part we're worried about. Well, if we take a look at this then, and we remember that we're writing this as an interval, our smallest y value comes first. So that's going to be 1. We're going to be closed at 1, and then we're going to be open. That grows without bound. So our y is going to go from 1, closed at 1, to infinity. That's one way to do it. Another way to do it is just to plug in your x values into this equation that you found, your Cartesian equation, and ask yourself, okay, what am I going to get? Now, they want us to draw the graph of y equals 1 over x, right? That's what part B says. Part B says sketch the curve. Well, the graph of y equals 1 over x, we were taught in pre-calc that this is the graph of y equals 1 over x. However, we have bounds, right? We have bounds on our domain. We know our domain is only from 0 to 1. So the part of the curve that we're interested in is the part that starts here it's going to start here at 0 and go to 1. 1's here. So our curve is going to be this piece right here. All right. So that will complete my questions on 1.7. Now, I'm also going to do an example or one of the problems that we had to work on from 3.4. We were assigned from 3.4 3 problems having to do with finding derivatives of equations when they're expressed parametrically. So we were assigned 79, 80, and 82. So I'll work on number 8. So let me erase this here. And that will give us a problem to look at from section 3.4 as well. So if we look at section 3.4, that's the chain rule, right? And we covered that in Calc 1, but we did not cover the parametric problems in Calc 1. So here, for the chain rule, I'm going to work on problem 80. Now, problem 80 is a trig-based question. It says x equals cosine theta plus, so x equals cosine theta plus sine of 2 theta. And they tell us y is equal to sine of theta plus cosine 2 theta. And they give us a point, theta equals 0. The instructions say, find the equation of the tangent line to the curve at the point corresponding to the given value of the parameter. So we want to find the equation of the tangent line. Now we know from Calc 1 that the equation of the tangent line is y minus y1 equals m times x minus x1. This is our friend, the point slope formula. And in place of m here, of course, we need the derivative. Because the derivative equals the slope of the tangent line. So the first thing we're going to have to do here is find the derivative. Now, these are given to us in their parametric form. So we use a version of the chain rule. We know that dy dx can be expressed as dy d theta divided by dx d theta, right? This is the chain rule when we've written it as a fraction instead of a product. So we're going to find the derivative of y with respect to theta. The derivative of sine theta is cosine theta, plus the derivative of cosine theta is going to be, cosine 2 theta is going to be negative sine 2 theta, but we have to employ the chain rules. We got to take the derivative of 2 theta, so we'll multiply that by 2, divided by the derivative of x. The derivative of cosine is going to be negative sine theta. The derivative of sine 2 theta is going to be plus cosine 2 theta. Again, we'll have to use the chain rule here, take the derivative of 2 theta and get 2. And now we're going to want to evaluate that at theta equals 0 to get our slope, right? And we'll do that work down here. We put 0 here, cosine of 0 is 1. We put 0 here, and that's going to be sine of 0, that's going to be 0. So that's gone. Put 0 here, sine of 0 is 0. Put 0 here, we get cosine of 0, that's 1 times 2, so our slope is going to be 1/2. Now, before we can find the equation of the tangent line, we have to find our point x, y, and we're going to find x by plugging in theta is 0, so x is going to be, cosine of 0 is going to be 1, sine of 0, because 2 times 0 is going to be 0, that's going to be 0, and then y is going to be sine of 0, I'm using theta 0 there, so sine of theta, sine of 0 is going to be 0. Cosine of 2 times 0 is still going to be cosine of 0, and that's going to be 1 as well. So our point is 1, 1, our slope is 1/2. So we get y minus the y coordinate equals 1/2 times x minus the x coordinate, and that's the equation of our tangent line. Question 82 is a little different than question 80. So I know I said I would do question 80, but I'll get you started on question 82 as well. Let me erase this. So in question 82, it says, find the points in the curve where the tangent is horizontal or vertical. Horizontal or vertical. Now, what we need to remember there is that horizontal lines if our line is horizontal, that means the slope equals 0. And if our line is vertical, that means our slope is undefined. So what they're really asking you here is to find the equation of the slope and then tell me when is it going to be 0 and when is it going to be undefined. So in 82, we're given the equations x equals 2t cubed minus 3t squared, 2t cubed minus 3t squared minus 12t, that's our x. And then our y equation is 2t cubed plus 3t squared plus 1. And again, we're going to have to start by finding the derivative, which is dy dx, or if we use the chain rule, dy dt divided by dx dt. Now, the derivative of y with respect to t is going to give us 6t squared, right, derivative, plus 6t. The derivative of x is going to give us 6t squared minus 6t. And if we factor this, right, we're going to get 6t times t plus 1 divided by 6t times t minus 1. Now, we're supposed to figure out when is our slope when does this equal 0? Well, a fraction equals 0 when the numerator equals 0, right? That's our rule, but we have to be careful here because if we just write this as 6t times t minus 1, sorry, t plus 1 equals 0, we're going to get t equals 0 or t equals negative 1, and these are going to be the two places that we claim the slope is 0, and therefore the tangent line is horizontal, but that's incorrect. Because we have a factor of t in the denominator as well. So if we let t be 0, we're going to get 0 divided by 0, which is undefined. That is therefore not a place where the slope is equal to 0 or where the tangent line is horizontal. Now, the other part of the problem asks, when does dy dx, or when is dy dx undefined? Now, to do this, typically you would set the denominator equal to 0. So you would get 6t times t minus 1 equals 0, and that would give you t equals 0 or t equals 1. And in this case, that's going to be correct because if t is 0, we're going to get 0 divided by 0. That's undefined, and therefore our tangent line is vertical. Or if t is 1, we would get 6 times 2, that's 12 on the top, and we would get 0 on the bottom, 12 divided by 0, undefined. Okay, so there's question 82 as well. All right. Hope this helps with your homework.